Welcome back to the ongoing devlog for Project Concordia. Last time, we took a look at implementing an unnecessarily convoluted runtime level editor for the game that's not even reached a playable prototype yet. During the devlog, we implemented both tile painting tools for walls and floors, as well as prop placement tools that allow the user to place many of the various entities that will populate the environment. Let me just start by saying, wow. This has been an undertaking. I promise by the end of this devlog you will see the map editor in action, but it took an extraordinary amount of time to finish this compared to any other mechanic I've implemented in the past. Enemies, which happened to be our starting point for this devlog, were previously the most time consuming, but creating their AI only took up half the time that this map editor took. But I'm sure you'd rather hear about the process I underwent to get here rather than hear me complain about the time it took. So as mentioned previously, we'll start with implementing enemies. Enemies are interesting. Unlike props, which are plug and play, enemies require specific setups, and that means just plonking down a prop definitely wouldn't translate easily. The enemy AI isn't anything crazy, but if you've seen the enemy-focused devlogs, you know that they do require some setup if you don't want them to just stand around doing nothing. That being said, our first step was to place enemies down as props. By just repurposing the code from our prop placement system, we can do just that. That's a good start, but now we need to establish some kind of rotation system. Props currently only rotate based on their axis if they are wall props, or not at all if they are equipables. And when static props are added later, they'll likely only rotate in increments of 90 degrees, so a new button needs to be added just by binding R to be the rotate key. Pressing just rotates the enemy through the ghost preview, and when placed, the placed enemy will be at that rotation. Here, I've included a dropdown that lets the user pre-select the weapon the enemy will have equipped. This data is stored in a placed enemy object similar to the placed prop objects I described in the last devlog. It tracks the same things as the placed prop object, but also tracks which equipable is carried. So now that you can place an enemy, you do need to be able to modify the details of said enemy. By opening a small window on the screen, we can display certain options as they'd appear in the editor. These options include a way to change the equipable the enemy has spawned with, as well as a patrol setting, and since the left click is assigned to selecting an enemy, the ability to move an enemy appears as a button inside the selection window. This data is all tracked within the placed enemy object, and is loaded on a left click and saved when deselected. In the case of tracking if an enemy is patrolling, that's easy. It's a simple bool. But tracking the actual patrol points is a little bit more complex. You see, the key issue here is that there is only one pop-up window for editing enemies. That means it needs to update with information from one enemy to the next, and to get that working, the list of patrol points need to be somewhat dynamic without constantly creating and destroying game objects, which could easily occur if someone was swapping between selecting an enemy with no patrol path and an enemy with a maxed out patrol path. I ended up limiting how many patrol points there were, so there's a set amount of 10 maximum patrol points available at any time. And based on how many points had been placed per enemy, a number of those 10 patrol points are loaded. This means just turning on and off which buttons are visible to the user. Limiting the amount of patrol points also helped me design how the patrol points would display visually. Realistically speaking, 10 is far too many patrol points, since the enemy patrols should be quite simple so the player can very quickly understand how the enemy will move. However, by setting a maximum of 10 rather than an infinite amount, I can select colours intentionally for each patrol point, and then draw lines between these points. By doing this, the patrol points follow an intentional pattern, specifically a rainbow pattern, where each point is tinted to the next colour of the rainbow sequence. The specifics of the patrol point data also isn't exposed to the user. They can see the visual representation of where the AI will target their pathfinding to, but not which path the AI will actually take, nor does it show the exact vector point. Instead, the patrol points are interactable solely through the color-paired buttons on the enemy editor window. I was feeling pretty confident about how easy it was to set up most elements in the game at this point through the map editor, but I still felt like there was some kind of missing element when interacting with the current interface. Mainly, it was impossible to tell when props and enemies could or couldn't be placed. Around here I did do a bit of refactoring, and opted to create as many generic functions as possible for reuse throughout the various systems. I use these to have several checks go through based on the location of the pointer. Essentially, these checks were already being run when the user hit left click, but I refactored them for simplicity and had them run during update to tint the ghost sprite red as a warning. There is just one more tab I had planned for the map editor for the time being, and that's the data tab, which contains ways to adjust a lot of the boilerplate data which doesn't really have a place anywhere else. This includes setting the level name, level description, a start location, and the map size. It'll also be where the user has access to save and load functions for editing between sessions. I don't think it's worth diving too deep on the first 3 items I mentioned. Name and description are just text fields that are saved when changes are detected, and the start location is placed almost identically to an enemy, just without the enemy edit window. The first actually interesting obstacle is the dropdown for adjusting map size. Now, don't ask me why I opted for map size to be a dropdown, but it just is. Maybe I'll change it later, but this is the system I've chosen to work with for the time being. Now, from the very start of this level editor detour, I've implemented the infrastructure to reference a singular map size. So far, this just determines how the grid displays and prevents props and enemies being placed outside of the map bounds, so changing that value is easy. The difficult part is adding the ability to shrink the size of the map while objects have been placed outside of the new bounds, or in other words, adding clipping or pruning when shrinking the map bounds. Some aspects of this were actually reasonably easy. By just going through the list of props and enemies and identifying which ones were out of bounds, they can be deleted and removed as if they'd been erased. Patrol points were a little bit more difficult, since they are an entry in an array rather than a scalable list. I decided to take a slightly messy shortcut, and any patrol point found out of bounds reset to absolute 0 in terms of position. This is a real brute force approach, and will likely be reworked later. The tile map was probably the most interesting to implement of the clipping functions I created. Basically, rather than chopping up the map and placing it back down, I figured I'd just erase the extra stuff in 4 big bounds. So if you can imagine a square inside a bigger square, I erased one big rectangle across the top and bottom and a small square on the left and right. Doing that got me the desired result and completed our pruning system. Alright. There's just one, sort of 2, functions left to do before this map editor is working, and that's saving and loading. If I had to guess, this is probably where I went wrong in terms of my implementation, but my plan was to convert the complex data into a series of arrays containing simple integers or strings to save to a text file, and then reading it back to load those things. But rather than reading and writing straight to a file, I thought it'd be best to have an intermediary. Despite knowing that scriptable objects do not work for this purpose, I decided to use them anyway, creating a map data scriptable object, which is essentially a big set of variables that gets passed data from our paint, prop, enemy, and data component, and stores that information for later use. Just having saving and loading working on an instance-based level was quite simple, really. I had a big array of integers representing the paint ID for the tile map, a smaller prop object array that tracked the prop ID, its location, and if it was rotated, and a more complex enemy object array that tracked enemy ID, its location, its rotation, its equipable ID, if it was patrolling, if that patrol was cyclical, and the patrol points it followed. I'm fully aware I've just listed a bunch of garbage at you, but I did create functions that could be passed this data, and would then load the level exactly as it had been saved, which was great, because if I couldn't get that working, I was seriously in trouble. That being said, I had to convert these props and enemy objects into even more granular plain text data to save to a file. I think. Once again, reminding you this is where I probably went wrong in terms of my implementation, but I just did what felt right. So by converting the arrays into strings split by commas and other delimiters, I ended up with something that looked a little like this, which, obviously, is terrible. For a couple of reasons, mainly the huge block of -1s. I did technically get this save and load working at this point, but I want to show one of my optimizations for this, which was to create an array of ID index pairs instead of saving the whole massive tilemap array, which let me shrink down the data saved by a pretty good margin. Anyway, this was the exact point where I realized that a scriptable object was not the way to go, but I pressed onwards regardless and added an import button to the scriptable object in editor to load the data from the exported text file and manipulate it in the editor. Finally, we have a file that could, in theory, be used to load a map dynamically. Essentially, by following a similar process as the loading function in the map editor, I created a function in the game manager that would pull the data from the scriptable object and instantiate all the necessary props, enemies, and tiles, setting them up as necessary, and letting us test out the level with ease. Genuinely shocked I got this working, especially considering it's been so long since I looked at some of the code for the game itself. I assumed it wouldn't work at all. I ended up adding a bit more functionality to load the map in editor for more granular changes, but ultimately setting up the bulk of the map in the map editor will be far easier than using Unity's default tools. So, with the level editor finally complete, we've arrived at the end of another devlog. If you enjoyed and you are interested in seeing more, go ahead and subscribe and turn on notifications to be alerted when the next video comes out. My next goal is to start working more on the visual presentation of Project Concordia and see if I can nail down some kind of vague aesthetic before moving forward.